Hello and welcome back to module number 10, and today we're going to talk about R packages. I will not go over step by step as about how to create a package. I will go only about the terminology in that entail to create a package. I gave you a lot of resource on the subject, and we have the book. The book is all about the package, and I want you to go over that. So my idea or this presentation will be about how we are creating the package. So one of the things that I want to wrap around your idea is what is ggplot2 and what is all the packages that we use throughout. So how do you know how to you're using a package? Had you install it? Have you load it? You remember how to install package, how to load package into the R environment? What happens when you load it? What happened to its functions, to the data? And what about the page that contained in each and every single package that you are creating? So a package is a bundle of stuff. I like to call that stuff, but it is also structural bound of stuff that we will go over and make sure that we understand what is it entail. So what is it? It is a structural standardized unit of our code, documentation, data, and also, and one of the most important aspect is external code that enable you to apply to it. So why use packages? I can use whatever the function that I use, declare them, and let user use them. So the idea here is the ability of finding, installing, compiling, and updating those packages is something that when you throw your functions out to everyone, they will not be able to update that. It will be something that it will be hard to do when you are creating a new function. Validation is another thing that is really important to packages. I'm sure that some of you already started to use specific packages that they check this validation and say, hey, your package is not updated. So validation is important. And one of the things that we did not talk about is the distribution of the package. Most of us will will try to submit packages through Crane and provide the code in GitHub. But there's other places that allowed us to store or to distribute the packages, and Bioconductor is part of this routine. That there's a lot of people in biology that use packages in order for them to analyze. So they created their own distribution, not part of Crane, about what is that the packages that delegate to biology or physics or chemistry. Documentation is part of the package, and it is part of the tutorial and demos and example that allowed you to do that. And last thing, that the organization of a package is really important, especially useful for programmers. And it has to contain names, it has to declare the enforcement dependency of other packages if you are going to run, example, in your package ggplot2. So you have to declare what is the dependencies of other packages. So we are talking about why do we use packages? We have to have installation and administration, validation, distribution, documentation, and organization. So how does the package actually works? And the idea here is a package is part of the R environment. You cannot create a package and then go to your browser and say, hey, I created a package in R, or why doesn't it work? It works under only the R environment. So you need to create the components of the R package that will fit into the R environment. And the R environment has some restrictions about what is it allowed and what is not allowed. So the package for you on stuff is to analyze your frequency, repeat, or share with others, and publication. It's all about publication, and if you have a popular package, that might be a good indication that you might have a job in R in the end of the semester. So handling the packages. So you need to load with a library. You need to have a package level help, which is where the library help the name of your package and the function it will tell. All those things, I want you to do research about what is the name, unique name that you're going to create for your package, and what function name that you're going to use. Example, a good name for a function will be something that describe your functionality. When I created the Lotka's Law package, it was very important for me that the functions that I create will match the functionality of the package or the aim of the package. So look at that and see what does it entail. For high-level department development, upload the detached package name, but you should not have done this if you don't need to. Handling the packages in R is quite simple, but I also gave you a lot of bookmarks that you can go over and use the textbook in order for you to do that. So some of the things that I'm going to go over is how to create a package in R. We are going to use 2 packages to do so, and those packages will allow us to apply to that. So when you start R, you have empty workplace, but there is also other basic stuff such as metrics and plot that are embedded into R. So it's like you have 2 boxes, your workplace and the core functions or core environment for R. Actually, it is a whole bunch of boxes. When you do search, you will find what R holds in the environment for you. So when a new package gets inserted near the front of the list, it can add additional packages which called dependencies. Example, I like that my Lotka's Law goes with hands in hands with ggplot2. So this is the ggplot2 is the dependency. You will also notice that each package has its own box or bundle in order for it to hold on to it and be able to update. One of the things that is really important for us to remember as R developers is that the RStudio always updates itself. There's always new updates. So one of the things that you will need to be open is that some of your users that will use your package will say to you, hey, I upload or update the RStudio to 3.001 and your package does not support that. So you will need to update your package as time go by in order for you to be consistent with the development. One of the things that we need to talk about is the structure. What makes a package that allows to have a structure of files and directories that will match to the RStudio. So if you will tell the R to treat a package, it will. But if you can create it by using the package skeleton, it will also show you. So if you will say package.silicon ggplot2, you will see the structure of the package and what is it consist of in order for you to understand what goes on behind the scene of a package. One of the basic description or basic requirement of any package in R is the description folder. It consists of your name, the author, the license, etc. Why is it so important? Because it is open source application, because it's very important for us to promote new user to use the R and to create their own package. It's really important that you will provide description into the package that include your name, the author of the package, the license, and what its intel. The license is usually about that you declare that this package is open to anyone to adopt or revise if they see it fit. Something that we did not talk about that in our class, but it's something that is really important for me. I feel that my work does not belong to me, it's belong to my community, and as a result, my work is shared by everyone else. So I want you to feel comfortable that in your you cannot close this gate and say, hey, this is my package, this is I will charge you from now. It will not work. It will not be acceptable by the R community. The R also has directory, and when you are going to create the package silicon, it creates a file per function. So there is no rule, but you can put as many functions into a single file. What is a man folder called? It is the help files that help user to see what it can help them in order for you to do that. When I created the purse package, which is still unclear, I did not finish it. One of the things that I got is that a lot of people ask for more help with regard to the foundation of the package. So this is where I can create the documentation that will help to document the function that I created. Main space folder is defined with the objects that are visible to the user and other functions. So it is the public versus the private to the package. The default to make everything visible that start with a letter. So this is the idea of namespace and what is it entail. The description, as I said before, depends on the package used by its and loaded and visible to the user. The import, the package used by this one but not loaded, and it is not visible to the user. So again, one of the things that it is a textbook talk about that the textbook is of our package is about the vinegar and what is it essentially give us in order for us to overcome that problem. So more advanced names for MySpace, example Alpha, example Friedman. I don't think there is a lot of Friedman into our packages, but maybe there is, because there is an economic law called Friedman law. So maybe someone will come up with an R package for that, but for now, until this morning, I did not see any Friedman package. So this is something that, again, this is what is important and how to implement names into it. I started to talk about vinegars and what is it stands for. So it allowed us to create what it stands for, the LaTeX R code, which is allowed us to produce a PDF available into the installation of the package. Why is that? Because if you have a help and your function is a little bit more complex, the vineyards create a PDF that is accessible to anyone who use the PDF viewfinder in order for you to see it. So again, this is something that our textbooks talks about, but I want to remind you to just to look at that and see what does it entail. Help on writing the packages, there's a lot of help in the web. There's a lot of tutorial how to do that. And so again, my hope is that instead of me trying to cover every single aspect of it, I want you to search the web. I want you to do the extensions and to see what does it entail and especially go over the textbook. The textbook cover it quite well with regard to the package. So again, this is what I want you to do. This is the basic steps that I want you to follow in order for you to create the RStudio. So again, create a blank project in R. So it's a good idea to save any existing work and then re-add those functions into a new project. So the package is always in a working session, which might be messy at times. So it is advised to create a blank project and start from scratch and then build your own package. So what you do, you are creating a project, new project, and when you click on it, it will help create a package. You will give it a name. You will also create, you can create a package file source, example, the R functions, and you're going to create the project subdirectory. But beforehand, before you're going to start that, I want you to install two packages in order for you to make your life easier. The DivTools and the Oxygen 2, in order for you to have this environment installed, in order for you to do that. And another thing that I want you to highlight when you are going to start this project is that you're going to create a repository in GitHub or GitHub in order for you to do that. So you are going to do to have that just for a backup and not send me email at 3 o'clock in the morning say, hey, I lost everything and my package, I cannot find my package. So the update version of DivTools is this is the installation. This is where you're going to find it. You're going to create many new files, data files, description files, main or help files, R folders that contain R as the extension of the functions, and you're going to read and delete me file that allowed the user to see what is it about, and get TWD, which return the working directory to the save location. So description, as I said, all information in the file, the title of the package, the version that you are releasing, the author, the maintenance person, the description, and the license. Usually, as I said before, I expect that the title will be the open source platform, which is stand for the G, and Y, which is the open source. Namespace is usually left, but it can be tweaked to create hidden function and package dependency. So it's always good to have that in the back of your mind when you are creating. So building your package, setting up the package settings, build a tab and build a check. Always check for errors. This is something that is really important. One of the things that if you're going to be serious about your R package and you want to submit it to the R Crane, they will check for errors. So make sure that you are clean about that and there is no error in your package when you are packaging it together. The Roxy Oxygen documents will set it up. So you're going to build it, select tools, you're going to configure it, and you're going to check all the 6 points options that are available in order for you to apply that, in order for you to create. So in this case, the Oxygen option windows, please select all 6, not only 3. I had students that last time selected only 3, and that's why this video of images consist of and not 6. Checked all 6. The Oxygen is the ability to auto generate documentation and file that you can later on go back to the package and fill it up yourself. Create and add new files to add or edit functions, you can do that by file, new file, R script, or you can save the R folder in the file display of the RStudio. So always make sure that you are compliant with what our textbook says about that. Always use the build tab as well, and always check your spelling and everything in tail. So build and check, make sure that all the functions are finalized. You build and check, so make sure that there is no error. So you will click on build and check all the time, and RStudio will build it as a tab, as easy development. So basically, you will see description folder file, you will see the main file, the R file, and you will tap into it and fill it up yourself if you want to. The RoxGen document build and checkup function start with that command in order for you to check everything, to make sure that everything is correct. And after filling up your syntax in your code, build and reload it again to make sure that it is compliance with the R environment. When you can view your document files by going to the package, checking your package name and clicking on the blue text, that means that the Oxygen created the help file. This is how it looks. You can edit it and revise it, but make sure that your function is entailed in the documentation. This is an example of package documentation. Make sure that you focus on adding notes to your functions, example prime, or example return, or example and so on. Build and check to compile your function and documentation, and this is the code in order for you to do that. This is my test function, and again, this is a simple function that entail if your main file, your function file name document will look something like that, that is a good sign, and this is what I expect you to have. Package function edit. At any time you can edit or add files to your folder in your package, so it's always not done until it's done. In the end, it will generate GAZ file format, which means it is like zip file, but it is a Unix machine, so it's tar.gaz format, and this is how you're going to upload it to Crane. So this is something that you need to be familiar with, and the textbook again talk about that, how to do that. And when you're going to test to see if you can install your package, you're going to say install, you're going to name your name and see if you can see if there is an error message you get. That's it. That's my 5 seconds introduction to our package. I know that I did not cover every aspect as you expect. I want you to use the textbook. In order for you to do that, I want you to search the web. Don't rely on me just to say, hey, you did not post it, so I cannot do that. No, I want you to search to find out, see how there is no one way or the highway. There is learn, implement, test to see if it works. And if it does, adopt it. So this is what I see as my methodology and my paradigm when I talk about R packages, especially for new users. This is where you learn more than just follow the rules. That's it for now. I hope you enjoy it. I welcome if you'll be able to finish your R packages. Welcome, congrats, and I will see you next time. Until then, have fun.